So, let us we will take today the alkynes topic. The alkynes may be defined as unsaturated aliphatic hydrocarbons with carbon-carbon triple bonds. Okay. Unsaturated means other than sp3 carbon, sp2, sp hybridized enes and ines containing compounds are unsaturated. Aliphatic means open chain compounds, there is no benzene type of the compounds. Hydrocarbons means they are made up of with only hydrogen and the carbon. Finally, the unsaturation is due to the presence of the triple bond. If the in this case, if it is double bond, they are called alkenes. So, alkenes and alkynes, the first line is same, both are unsaturated aliphatic hydrocarbons with double bond alkenes, with triple bond alkynes. So, the first example is here, the smallest alkyne is 2 carbon alkyne, that is systematically they are named as alk plus ene plus alk plus ine plus E. So, the according to this the nomenclature 2 carbons are there, therefore, eth ine E, ethine. However, they also called as this compound is also called as acetylene. The acetylene is a common name. Much prior to this IUPAC system, the gas is well known. So, it was named and called by this name acetylene. So, ethine is a systematized name. Now, similarly, if the little bigger compound, if triple bond is there, they are called 3 carbon, therefore, propyne E, propyne. This is called taken as a acetylene plus 1 CH3 extra, except this CH3 it is nothing but acetylene. So, we have a common name, this is a common name, methyl containing acetylene. So, methyl acetylene. Similarly, if 4 carbons are there, when 4 carbons are there, triple bond can be in the between 1 and 2, or it can be between 2 and 3, both are butynes now. So, one has to say the ine started on second carbon here, first carbon there. So, it is called 1 butyne and the other one is known as 2 butyne. In fact, you can say but 2 ine or but 1 ine, better the number is used in the 5th portion. So, therefore, it comes under the name 2 butyne 1 butyne. They may be also named according to the acetylene, that is substitution pattern. The acetylene is taken as a main compound and this group is taken as an extra. This is called ethyl containing acetylene. So, let us call it as a ethyl acetylene. And in this case, these 2 methyls are extra. So, I call it as a dimethyl acetylene. And if one benzene ring is there, benzene with, in this case the benzene is called not benzyl but phenyl. So, systematically it is called phenyl containing ethine. So, you may call it as a phenyl ethine. Common name may be phenyl acetylene. And so on. Bigger the compound, complicated and so on, all the groups will be mentioned and longest chain will be selected according to nomenclature of IUPAC or according to the acetylene oriented, it is substitution nomenclature, both can be extended and there names can be named. So, now let us go for some methods for the preparation of these alkynes. So, let us see some methods for the preparation methods. In the alkenes, the double bonds can be prepared from by converting triple bond or single bond to double bond. Here we don't have that addition methods, only elimination methods are applicable. Based on the elimination methods, the acetylene can be prepared. The first method means the minus of HX. However, 2 moles you have to remove. 2 times if you remove the HX, 1 HX if you drop out, like for example 1 hydrogen and 1 halogen if you can remove, you get double bond formation, right? But in order to get that 1 more pi bond, 2 pi bonds are there, so 1 more HX should be there. This compound you can also have another type. The halogens can be here 1,1 type. You too can have halogens side by side also, okay. In this case also the hydrogens here, the HCl is eliminated here, the HCl and the HCl is eliminated. Again you will get the 2 minus of 2 moles of HX and will get the acetylene. So this what reagent can, the removed molecule is HX, that means if X is equals to Cl, hydrogen Cl, that is hydrogen chloride, is an acid. So the acid how to take out means a strong base should be used. So it takes place actually in 2 steps. In the first step what happens, 1 HCl will be removed, still 1 H and X will be there. So second step, 1 more HCl will be removed, you will get the acetylene. So the product formed in between is called vinyl halide. Vinyl halides have some small phenomena. Having a lone pair, they can show resonance phenomena and they get stabilized. Therefore, second step will be slightly difficult when compared with the first step. Both are elimination, but it is slightly difficult when compared with this one. So that's why in the first step what you use, second step may not be that much useful. In the first step we use alcohol dissolved KOH. Just boil for some time, you will get it. Second step, same reagent may be used, but as I said it is difficult, therefore the product may not be formed excellently. Instead of alcoholic KOH, go for the sodamide, NaNH2 is known as what? Sodamide. Sodamide is found to be a stronger base than the alcoholic KOH, therefore second step once again HCl remove and reacts with NaNH2 forming NaCl and the ammonia. So, you will get acetylene formation. So, either by the 1,1, this is called 1,1 or geminol type, gem dihalo compounds. Here 1,2 system it is, 1,2 dihalo, or you can say vicinal dihalo. Either of the dihalo compounds can be taken and can be successfully one after the one, 2 times HX can be removed, you will get the acetylene. So, this is the one method, this is called what? Dehydrohalogenation. Dehydrohalogenation of geminol dihalides or vicinal dihalides, both successfully gives the alkynes. Second method will be minus of X2, this is called dehalogenation. Dehalogenation, that means 2 halogens are removed. Again if 1 X is removed, 2 X's are removed, get double bond. We want a triple bond. So, therefore, a compound should have a 2 sets of halogens. This is 1 set of halogen will create the double bond. But we want 1 more bond. So, let us have 1 more X and X. Then in this case twice the HCl is deleted, Cl2 is deleted, and you will get triple bond formation, right. So, this type of compounds are called 1122 tetrahalo, 1122 tetrahalo alkanes, 1122, that means in the first carbon 2, second carbon 2 halogen. Halogens can be here, X can be here chloro or bromo. Even iodine you can take, but iodine doesn't require any reagent, automatically deiodination takes place and you will get it. So, that is why the dichloro or 2 chlorines, 2 bromines, mixed type also it is okay. So, but a tetrahalo compound containing the 2 halogens on the first carbon, another set of halogens on the next carbon. This is done by the reagent zinc. This original, the tetrahalo compounds are liquids. So, you take this liquid, add some this zinc powder or zinc dust, solid one, it is heated for some time, boil it, then the zinc takes away this halogen, forming the 2 moles of Zn(X2), and the compound becomes into an alkyne. Depending upon the side by groups, you will get the extension of these groups this side, that side. If hydrogens are there, simple alkyne, that is acetylene, can be prepared. So, let us go for the third method, preparation methods under that. In the alkynes, we have a removal of HOH, that is known as dehydration, but dehydration methods are not useful to prepare the alkynes. You can have a minus of CO2, this is called what? Decarboxylation. It can be used successfully, decarboxylation. We have seen in the preparation of alkanes like this, that is a sodium acetate, adding water, electrolyze it. This is Kolbe electrolysis, known as Kolbe electrolysis. In the electrolysis, what happened? This anion goes to the anode, becomes into free radical and cuts into dot dot, and this dot will become CO2, and this dot joins, you will get a alkane preparation. That was the preparation for alkane, in fact. But now what we are doing is, if already one bond is there, so one more dot and dot, from this side one dot comes, it makes a double bond. So, the method can be extendable for the double bond. If the compound is already having a double bond, that is now what we are taking is disodium. If the COOHs are same side, it is called disodium malic acid, therefore maliate. You too can take the 2 COOHs on the opposite side, it does not matter. Anyhow, you are going to forego this NCO2 groups. So, you can have a disodium salt of fumaric acid, so you call it as a fumarate. Disodium maliate or fumarate, either one, add water and do electrolysis, the CO2 will be removed. First anion, as I said, goes to the anode and becomes dot, and it breaks, CO2 will be removed and a dot dot will be joining, and you are getting a triple bond now. Okay. So, in both the cases, the triple bonded compounds are formed. So, depending upon the XY or R1, R2 groups, the groups can be retained here, but the 2 moles of carbon dioxide will be released. If you take 2 hydrogen, that is H2O, and you get the 2 NaOH, and the 2 H2 are formed at the cathode. These 2 are released at the cathode, and these 2 are released at anode. Anion goes to the anode, anion becomes into compound and the CO2. Therefore, you can bifurcate the 4 products into anode products and the cathode products. So, one of the product in the anode is alkyne. So, the method is called what? Kolbe electrolysis. As I said, there is no bond, bond comes, alkanes are forming. Already bond is there, alkenes are forming. If 2 bonds are there, then geometric isomers will come, same side maleic, opposite side fumaric. Both acids take disodium salt, dissolve in water, make solution and electrolyze it, you will get the acetylene and their products can be prepared. You can have a one method which is similar to the Wood's reaction type also. As we have seen, the alkyl halides with sodium metal will undergo a coupling reaction called Wood's coupling reaction, and you will get the RR, right? In this method we know it. Similarly, a compound like 2 halogens are there, use the zinc metal and you will get a, this is also undergoes a coupling, and 2 zincs are used and you will get a double bond formation. So, I am just giving a comparison of the reaction. Now, what we are now taking is an alkyne containing 3 halogen. You can have an extension or simple 1 carbon chloroform. Example, trihalomethane or chloroform you can take. Add the silver metal, 6 silver atoms, this side 3 halogens, that side 3 halogens, 6 silver halide will be removed, and you will get the coupling of this carbon with that carbon with a triple bond formation that results in the acetylene formation. This is what our now the context. If there is no bond, a bond has this is nothing but the Woods coupling reaction. Woods coupling reaction. Similar reaction is extended for even for the alkenes preparation. The terminal carbon is having 2 halogens, 1 dihalotype, and zinc is heated, then this type of coupling takes place, alkenes are formed, 2 compounds. It is not elimination. In the elimination, no doubt alkenes are coming, but this alkene formation is not elimination, it is a coupling reaction, similar to Woods reaction. Now, here also 3 halogens are there, all these 3 halogens are eliminated, you will getting a acetylene type of the compound. It is an extension to the Woods coupling reaction, but you can say in this particular case you can have a R group or a little longer chain having a terminal trihalo can also be extended for the alkynes preparation. All these 4 methods are in the laboratory, they are fine, but we have some commercial methods also which are in the large scale for the profit oriented reactions. Those reactions are called commercial or industrial methods. So, the 5th method is called industrial method. Or commercial method. On a large scale, the main aim of this method is how best we can make the money, isn't it? So, in this method the point again will be the materials what we use should be the low cost, and in a large scale we must be able to prepare the product. So, for this method we are using the calcium carbonate, which is called a limestone. So, the limestone is from the earth digging we get. So, it is a considerably it is a low cost one. When you heat strongly, carbon dioxide will go out in a big kiln. We can go for this heating. So, the carbon dioxide will go out. In the kiln you find calcium oxide formation. This is called quicklime. Generally the quicklime will be added some water and used for the whitewashing of the walls. Now, we are using this quicklime by adding some carbon from the coal. So, this is our now second ingredient. First ingredient is limestone, second one is coal, both from the large scale from the earth layers we are getting. This coal is added and heated around 1000 degrees centigrade. This is also you need not to have a separate furnace. The coal itself produce on burning, so that heat is enough to react. So, the calcium oxide with the carbon forms into calcium carbide. This is called what? Calcium carbide. This calcium carbide will have a structure like this. Already triple bond is there, it is a minus and minus. Calcium is a +2. So, ionic bond will be there this side, that side. So, calcium +2 is balancing this -2 of the acetylide anion. What we are doing is now in the last stage is you just add water to this one. No need to heat or do any catalyst or something, just add water. The calcium carbide breaks into 2 pieces, adding hydrogen to the carbon, OH to this one. Similarly, H this side, OH this side. So, one side you will get acetylene, the other side you will get calcium hydroxide. So, one main compound is our acetylene compound is formed, and the other one is a calcium hydroxide. As we add more water, the calcium hydroxide will be soluble in water, it will be in the form of solution. But acetylene is the one which is insoluble in that, it is a gaseous compound, will come out. So, even the preparation, that is purification and that collection of gas over this liquid is also somewhat easy. So, the ultimately all favorable points are there. The cost of the limestone and the coal heating with the same carbon and another reagent water, that is also not a costly one. So, you can get this acetylene at a cheaper rate. So, the preparation of this acetylene in this method generally happens to be an excellent commercially profitable oriented reaction. However, we have one more method in the last method. In this method, we are not going to prepare the triple bond. We have constructed, isn't it, so far. But in this method, we are not going to prepare the triple bond, but we are taking one alkyne and converting into the another alkyne, like you can say it as a therefore conversions. Conversion of one alkyne into other alkynes. There are 3-4 methods are there. In 1A method, let us say in the first method, you take acetylene, treat it with the sodium metal. It consumes 2 moles and both the sides you will get a sodium salt. Sodium acetylide is formed, liberating the hydrogen gas. In fact, this H detaches as H plus. The H plus will take one electron from sodium, becomes into H dot, such 2 dots H dots will become H2. Now, Na after losing electron, it will become a Na plus, so it will become a salt. This is called disodium acetylide. Disodium acetylide, it is a salt, solid one. This disodium acetylide, you add some alkyl halide, both the side the NaX will be removed. So, 2 moles of alkyl halides are useful. So, both the sides R group is replaced with the sodium. So, you will get dialkyl. At a time you will get the 2. So, dialkyl acetylene is formed. So, in this method 2 alkyls, both the sides 1 we are able to get. So, the method is useful. For example, if somebody asks how do you convert acetylene into the 2-butene, that means the R's are methyls. Okay. This is 2-butene. Similarly, 3-hexane, all symmetrical type. This type of compound, both the sides ethyl groups. So, what you do is first add sodium, you will get disodium acetylide. Then instead of Rx, that means in the place of Rx, use methyl chloride so that 2-butene comes. If you use ethyl chloride, you will get 3-hexane. This is 2-butene. This is 3-hexane. Similarly, 4-octane and so on. Both the sides R's are symmetrical type. 2 R's, identical R's at a time are coming. This is in the 6th method A, that is first of the method of this conversions is acetylene can be converted into 2-butene, 3-hexane, 4-octane and 5-decyne and so on. Symmetrical type of the alkynes can be prepared. So, let us take another method, B method under this conversions. In this method, the acetylene is treated with sodamide. Sodamide is found to be a little less basic than the sodium. So, many books are saying that though there are 2 hydrogens reactive, one side metal comes, that is monosodium salt of the acetylene is coming, monosodium acetylide. However, if excess sodamide is added, you will get both the sides, monosodium acetylide. But with the sodium, you cannot control the reaction, both the sides you will get monosodium acetylide plus this NH2 and H forms ammonia molecule. This one, when you treat it with the Rx, so 1 R coming, that is monoalkyl acetylene. Monoalkyl acetylene is formed. In this method, 2 alkyls at a time. This method, 1 alkyl comes. We have one more method. Acetylene may be first converted into the monoalkyl by using the sodamide, followed by the Rx, So, first let us get the one alkyl group, right. Then you use the again sodium metal. So, this side sodium will come, then you use the alkyl halide. Let us have a, this is the R1, so that R1 has come, this is the R2 dash, R dash will come here, R2 dash when I use a, one side A you will have a R dash, other side you will have a R2 dash. So, two different alkyls if I want, I will go first using the A method, B method, using the B method you prepare first a monoalkylated derivative, then using sodium is A method in fact. So, go for the A method, then introduce the other alkyl leftover one. So, two different alkyls, for example, an example, if 1 butane is asked from acetylene, how do you prepare 1 butane? 1 butane preparation is like this, B method. Use sodamide and then in the second stage ethyl chloride if you apply, one side ethyl containing acetylene. If 2 butane is asked, 2 butane means center, that means this is A method. Using the A method, make disodium salt and use methyl chloride at a time, two sides methyl will come, right. Now, this C method means first get one monoalkyl method, then again prepare the sodium salt, then introduce another alkyl which is different from the first one. In this case, which should be first one, either methyl or ethyl, you have an option, either one you can introduce methyl or ethyl, that gives the scope for the preparation of this compound in fact. So, two alkyls one after the one you have to introduce, you cannot mix a methyl chloride and ethyl chloride and add it on the disodium, that is not the correct procedure, you will get a all homologous series containing the alkynes. Instead, if two different alkyls means first introduce one alkyl whichever you like, methyl or ethyl, then that monoalkylated treat it with sodium, get another side sodium, then treat it with the R2 dash, second type of the alkyl may be introduced. We do have a slight variation in the preparation of monoalkyl. You take the acetylene, treat it with the RMGX, alkyl magnesium halide. Now, the alkyl is a minus party, the minus reacts with the H, forms into RH. Then you will get acetylene is converted into an acetylene magnesium halide. Then RH will come. This RH in fact we are not going to take it into the product. This salt is now extended into the product. So, this salt is treated with the RX. So, the salt is having a minus that attacks on the R, and then MgX and X goes out as a MgX2, and this will converted into the alkyl containing acetylene. So, the R comes from alkyl halide. Okay. So, the magnesium halide will be the byproduct. Now, a question may be asked, for example, I want a phenyl here, phenyl containing acetylene. What type of RMGX should be taken? The answer is not phenyl magnesium, because this R goes out as an alkane, right. So, here you have to take as a phenyl chloride, whatever the RMGX you use it, but after getting the salt use phenyl halide, so that the phenyl comes into the compound. So, what RMGX should I use means, one answer is any RMGX which you like, but here it should be the phenyl chloride. Second answer is, instead of any alkyl halide, better go for the methyl magnesium chloride. What is the advantage in the methyl magnesium chloride means, this is the smaller one, isn't it? Methyl magnesium chloride is the smaller RMGX, cost will be less, and the smaller one gives an alkane which is also a smaller. So, smallest alkane, that is methane, comes as a product which will have a very low boiling point. So, definitely in the at room temperature gas, therefore, Even at low temperature also it will be gas, therefore the gas is liberated and goes out. Anyhow, that alkane we are not interested. We are interested in the alkyne preparation. So if you use methyl magnesium halide, the methyl and the hydrogen, methane gas is formed which goes out. Otherwise, if I use phenyl magnesium chloride, you get a benzene here. The benzene will have a at room temperature liquid at 80 degrees or so it boils. So to separate this benzene, I have to heat this mixture in order to get rid of this benzene, isn't it? So therefore, better use a methyl magnesium chloride. Whatever the R you want, here you use methyl magnesium chloride only better, so that methane gas goes out and salt comes. This is solid, for which you add the desired Rx. So if you want phenyl, you use phenyl. If you want ethyl, you use ethyl, and so on. So Ra, what you want R will be here, you have to fix that R and then use such type of the alkyl halide, so that desired R containing acetylene can be prepared. So in all these A, B, C, D methods, we are not going to construct the triple bond. We are converting one alkyne into the preferably a next higher or the then next higher homology of the alkane. This is called ascending the series. In fact, acetylene to propine, propine to butane, the series increasing is called ascending the series. Such type of ascending the series can be done by the sixth method. It is not actually preparation of a triple bond. We are converting the alkynes into other alkynes, isn't it? In the conversions are application of this metal containing acetylene. They are called metal derivatives of alkynes. In the metal derivatives of alkynes, this is the one of the application.